heterogeneous electronic health record system via text-based code embedding. The main problem here that the paper is addressing is using a code agnostic approach. Usually in code embedding approach, medical code embedding is used, which is not transferable. So here the novelty is to use the code descriptions and pass those descriptions through an embedding text encoder to create a contextualized common embedding space, and through which it can predict do the predictive task more effectively with more data from multiple hospitals pulled together. There are multiple settings it can be used: single domain learning, transfer learning, or pooled learning. They also introduced the idea of value embedding method, where the values are being captured and as used as a separate embedding on top of the description based embedding to enhance the performance of the model. So this is definitely opens the door for using the data interchangeably to do the predictive task. And we have the two hypotheses we picked. The first one we picked as for the pre-training. Basically we are using DESC-EMB RNN as the embedding model and train it with the database, mimic database, and then we are doing the code EMB with the what-to-wake approach and see how it compares in terms of average loss. In the second hypothesis, we trained the EHR model with code EMB and DESC-EMB as the embedding model, and RNN at the prediction layer with one predictive task called mortality, and we use with and without value embedding method to see how it impacts the performance to cover the ablation. Rest of the details are given in the report, and keeping the time in mind, I'm just going to run all the cells to show that they works. Here we have the instruction given for source code setup. If you run the Colab book in your personal drive, the download instructions are given. Pre-processing code covers the pre-processing data, and when you are pre-processing, we are using the data type pre-train as an argument. And then in the training, we are using DESC-EMB model training with MLM at the first step. And then code EMB with what-to-wake. For demonstration purpose, we use 10 epochs, but in the main report we have given the results with more number of epochs. Learning rate, we use 0.001 to finish it within the timeline. In second hypothesis, we have to pre-process again without the data type pre-training to create the files. As you can see, there is only 66 samples in the demo database for the mortality task, and due to the small data set, we have seen the model is basically overfitting, and that's why we don't have full confidence on the results. But in terms of model functionality, we definitely can say that as it is overfitting with a small data, it passed the sanity check. And at the end, we have discussed the results and discussions and our future plan, what we could do with when we have a better resources, and we can run the experiment with the full data set. Thank you.